The engine is the heart of the car because without it, the car can't move. But car makers don't just put an engine in the car and call it a day. They want to do their best to beat out the other teams. This is why Toyota always works on the engines of its cars. The Japanese company's newest engine blows everything else out of the water. What is Toyota's new engine and how much power does it have? Stay tuned because we're going to tell you about Toyota's crazy new engine that changes everything in this video. Toyota is one of the best car companies in the world. Last year, the company sold almost 10,500,000 cars, even though the industry as a whole wasn't doing so well because of the COVID-19 pandemic and the lack of chips. Why do so many people all over the world trust Toyota? There are many reasons why. Toyota still makes good cars, and most of its models are in the top 10 in almost every category, even though the competition is getting tougher. The company also makes a lot of different cars, so everyone will be able to find something they like with a Toyota or related badge. Toyota has more kinds of cars than almost any other company. Toyota cars sell for a lot of money because they are well made. You can even buy a used Toyota and expect to get a good price for it when you sell it in the future. Spare parts are easy to find, which is another thing in Toyota's favor. You don't want to buy a car and then have to wait months for a repairable part to be shipped from the country where it was made. The brand is well known everywhere in the world. So, if you drive a Toyota in a remote part of South Africa or a town in Bangladesh, your dealer will be able to get you spare parts. Also, there are mechanics everywhere who can fix Toyotas, so you can be sure to get technical help when you need it. But there's another reason why people rush to buy Toyotas: the engine. Toyota has made the best engines in their class by putting a lot of effort into research and development. Before we continue, if you want to support this channel more, you could join our membership program and try our super thanks, wherein your comments will be highlighted. Now, let's continue. The engine. In 1934, the company made its first engine, which was called the Type A engine. That was 2 years before the Toyota AA. The company's first car for people was made in 1936. In May 1934, Toyota started making prototypes of the cast parts that would be used in the Model A's engines, cylinder blocks, and pistons. These prototypes were based on sketches of the 1933 Chevrolet sedan engine. It was hard to make the core of the water jacket, which is where water flows to cool the cylinder block. In August of the same year, a cast cylinder block was finally made with the help of an oil core tube that company leaders had brought back from the US. The prototype engine was done by Toyota on September 25, 1934. Cast parts like the cylinder head, cylinder block, and pistons were the only ones that were made in-house. Crankshafts, camshafts, valves, plugs, and electrical parts were all bought from Chevrolet. But when Toyota put the prototype engine into a Chevrolet truck and drove it, the engine could only make 48 to 49 horsepower instead of the 60 horsepower that the Chevrolet engine could make. After looking at documents from other countries and redesigning the cylinder head to fit the swirl combustion chamber, the engine was able to make 65 horsepower, which was more than the Chevrolet could do. Toyota has grown from those humble beginnings to become a master at making engines. For example, it made the 1JZ GTE inline-6 engine, which has a power output of 320 horsepower and a torque output of 315 pound-feet. The success of the MK4 Supra is due to the 6-cylinder 2JZ GTE engine that is under the hood. For more than 20 years, applications with up to 2,000 horsepower have shown that the 2JZ is almost impossible to break. All of this is made possible by a strong cast iron block, which means you can get up to 750 horsepower with very few changes. The 4A GE inline-4 engine was also made by Toyota. It was rated at 112 horsepower and 97 pound-foot of torque. This engine was one of the first fuel-injected 4-cylinder engines with a twin-cam, 16-valve design. It was loosely based on the legendary BDA series of engines from Cosworth. Even though it's been almost 30 years, the aftermarket still loves this classic 4-cylinder engine as much as ever. Dynamic Force Engine. But with a dynamic force engine, Toyota has stepped up its engine game to a whole new level. This new engine has the most efficient use of heat. To fully understand this new engine, you need to know how well gasoline transfers heat. The term means how much of the potential energy in gasoline is turned into power that your car can use to move. Internal combustion engines do this by spraying a fine mist of gasoline into a mixture of gasoline and air in the cylinders, then squeezing the mixture as tightly as possible with a piston and lighting it with a spark. When it ignites, it explodes and grows, pushing the piston back out with a lot of force. The pistons turn the crankshaft, which is connected to the transmission, which is connected to the drive shaft, which is connected to the wheels. Various parts and gears in between direct and control the power to make sure the wheels turn, but not so fast that they spin faster than the tires can handle. But there's a problem with the plan you just heard. When the fuel burns, some of the power is lost because of friction and too much heat. This means that the average engine that runs on gasoline is only about 35% efficient at using heat. Engineers have been working hard for more than a century to find ways to save energy and use as much of the energy in gasoline as possible to move cars or power air conditioners. The engineers at Toyota looked at every part of the engine cycle and tried to find ways to make it not only use less gas, but also work better overall. Then, they looked for ways to turn the gasoline they saved into more power, which would increase the thermal efficiency. Toyota got ideas from Formula 1, where efficiency is the most important thing. To get high-speed combustion, the company used several ideas from racing cars. 3 changes in particular helped Toyota achieve high-speed combustion and make sure that the mixture of air and fuel burns more completely. This means that every combustion makes more power. One of the changes is the angle of the intake valve. Laser-clad valve seats and the size of the cylinder are also new. The angle of the intake valve and the shape of the intake port work together to direct the air-fuel mixture into the cylinder in a certain way. This helps the mixture burn more quickly and evenly, making more power and less waste. Second, the laser-clad valve seats make it possible to adjust the angle of the valves and the direction of the airflow to create tumble flow. This is a more controlled swirling pattern in the combustion chamber that spreads the air-fuel mixture more evenly before the compression phase. Third, if the cylinder is taller and narrower, it takes the igniting mixture less time to spread out across the cylinder. This again speeds up the moment of combustion, and more of its force pushes the piston down, which gives the engine more torque and makes it more efficient. Toyota engineers didn't stop there. They also used other tried-and-true methods to make the new dynamic force engines as thermally efficient as possible. Toyota's D4S fuel injection system uses both direct and port injection. During normal driving, the two systems work together to make the engine run more efficiently and more smoothly. When maximum power is needed, only direct injection is used. Additional strategies of Toyota. The pistons themselves have a special finish that reduces friction. An electronic thermostat and an electric water pump work together to control the temperature for maximum efficiency. variable valve timing makes sure that the power-to-efficiency ratio is at its best, and a higher compression ratio increases efficiency even more. All of these strategies add up to a world-best 41% thermal efficiency in hybrid applications and 40% in gas-only vehicles, with more torque and power at any engine speed and better fuel efficiency and fewer emissions. Toyota's new dynamic force engine helps it fight for every percentage point in the race to be the most efficient. The 2.0-liter four-cylinder engine works with a new 6-speed manual transmission that Toyota made to meet needs around the world. The transmission is smaller and lighter than Toyota's current one, and it can match the engine speed. Toyota put the dynamic force engine in the 2002 Toyota Camry. The engine is tuned to make 209 PS and 253 Nm, which is 25 PS and 8 Nm more than the previous port injection Camry. With this engine, the 2002 Camry now has better acceleration than cars like the Honda Accord. The car pulls hard, but the Accord can't keep up. Wapcar took the car for a spin, doing what they called hard driving for more than 300 kilometers. The Camry used an average of 7.7 liters per 100 kilometers, which is pretty good considering the type of road, the amount of traffic, and the speed of the car. The Camry's naturally aspirated engine also makes going around a series of turns much more fun. And that's it for today. Let us know what you think of Toyota's new dynamic force engine in the comments section below. Thanks for watching. If you're new to this channel, please subscribe to be updated for more upcoming videos like this. And if you like these videos, don't forget to hit the like button, or you might want to check out any other videos on this channel. See you at the next one.